Welcome. In this video, we will learn a rule for multiplying fractions, but not just that, we will also learn why that rule actually makes sense. So I want to show you first how we can think visually about multiplying two fractions, and only then move on to the actual rule. So a fraction is a part of something. The fraction 3/4 means that I have 3/4 of something. For example, this square. So 3/4 in this square could look something like this. Divide it into 4 quarters and then take 3 of those quarters. Now what if I ask how much is 1/4 of 3/4? So I'm not taking 1/4 of the entire square, not just one of these pieces. I'm looking for 1/4 of the green part. Well, in order to find this, we can divide the square into quarters again, but now using horizontal lines in the other direction. So 1/4 of this square would be this area, this blue shaded or hatched area. The horizontal lines that I used to get this area also divide the green area into 4 equal parts. So 1/4 of the green area, that will be where the green and the blue areas overlap in this red rectangle here. So how much is that as a part of the square? Well, it's 3 little squares out of 16 little squares in total. So 1/4 of 3/4 is apparently 3 out of 16. Let's use this technique again. How much is 2/5 of 2/3? Let's first divide our square into thirds and take 2/3. And now in the other direction, we divide it into fifths and we take 2/5. And we can find 2/5 of the green area where it overlaps with this blue area. So that's here. How much is that of our original square? Well, we have 4 little rectangles here. Out of 3 times 5 is 15. So it's 4 out of 15 or 4 over 15. So this works quite well. Let's try it again and ask what is 2/5 of 3/4. We take 3/4 in one direction, and then we take 2/5 in this direction. And again, we look for the overlapping area. That's these 6 rectangles. Out of 4 times 5 is 20 rectangles. So 6 out of 20. And we can, of course, simplify this fraction, dividing the numerator by 2 and the denominator by 2, and we get 3 over 10. Now let's see if we can use this to find a rule for calculating the result without actually looking at this square. So we're going to take 5/8 of 5/8 and we look carefully where our numbers actually come from. So we take 5 parts out of 8 in this direction and then 5 parts out of 8 in this direction, and we look for the overlapping area. Well, the overlapping area here will be these 25 little squares. And we got 25 because we multiplied 5 by 5. And we saw those numbers already in our original question. They were the numerators of our fractions. Into how many squares have we divided the entire square? Well, into 64, because that's 8 times 8. And we already saw those 8s in our original question here. So our result is 25 out of 64. And we got 25 because we multiplied the numerators, and we got 64 because we multiplied the denominators. So using that, can you predict what the result of this multiplication will be? 3 over 7 times 5 over 6. So based on what we just saw, we would expect this to be 3 times 5 is 15, and 7 times 6 is 42. And let's go verify this. Well, we take 3 parts out of 7 in this direction, and then we take 5 out of 6 in this direction. So 5/6 of the green area, that will be where they overlap. So that's this area. That is indeed 3 times 5 is 15 rectangles. Out of 7 times 6 is 42. So indeed, this works, and we get 15 over 42, which we can simplify because both are divisible by 3 into 5 over 14. So that means we don't have to keep drawing squares and rectangles. We can use a rule just based on the numbers that we see in the fractions. So when we multiply 2 fractions, we get a new fraction in which the new numerator is going to be the product of the two numerators, we multiply them, and the new denominator is going to be the product of the two denominators. We multiply those. By the way, don't memorize this as a formula. Just remember what we did in this simple example, and of course remember why that worked. I'll show one more simple and one more complicated example and then end with 3 practice exercises. Can we multiply 1 over 10 by 2 over 5? Yes, we can do that. The new numerator will be 1 times 2 is 2, and the new denominator is 10 times 5 is 50. And we can simplify this because both of these numbers are even, and we get 1 over 25. Now this rule works when we have just fractions. It will start breaking down if we look at mixed numbers, like 2 and 4 over 5. And this is also a bit more difficult to visualize using squares. Not impossible, but it's more convenient to try to stick to our rule now that we have it. So what do we do about this? Well, we can turn this mixed fraction into just a fraction of 2 integers. So what we're going to do is we copy the entire expression, but now we want to turn this mixed fraction into just some number over 5. How do we do that? Well, this 2 is already 10 over 5, because 10 over 5, that's 10 divided by 5, and that's 2. So in practice, you usually quickly say to yourself, 2 times 5 is 10. And the reason for that is that 10 over 2 is 5, so 2 is 10 over 5. So we have 10 fifths, but we haven't used these 4 fifths yet, so we add those, and we get 14 fifths. So usually you do all of this in your head, and then you just write down what we have over here. 14 over 5 times 5 over 8. Now we can start multiplying, but actually I already see coming here that I'm going to get a number here that is divisible by 5 as the numerator, and I'm going to get a number that's divisible by 5 as the denominator. So why not immediately simplify that and take out those 5s and write down 14 over 8. And actually I can simplify a little bit further here and divide both of these by 2 and get 7 quarters. And then I see 4 quarters already make 1 whole. So this is 1 and then 3 quarters. So this is a bit more difficult. Let's look at some more practice exercises. See if you can solve these by yourself. So try it first, pause the video, and then after you've solved them, come back for the solutions. So the first one is quite straightforward. Numerator times numerator is 6, and denominator times denominator is 40, and we can simplify to 3 over 20. The second one is a bit more complicated. We first want to rewrite these fractions, both of them, as what are called improper fractions. So 1 and 1 over 3, that's 4 over 3, and 2 and 1 over 3, this is already 6 over 3, plus 1 over 3 is 7 over 3. So this is 4 thirds times 7 thirds, 4 times 7 is 28, 3 times 3 is 9, and then we can take 27 over 9 out, that's 3, so 3 and 1 over 9. And finally, if the integer here confuses you, then you can always rewrite an integer as a fraction simply by dividing it by 1. So 7 is the same as 7 over 1. And now the rule applies again. 7 times 2 is 14. 1 times 5 is 5. So our new fraction is 14 over 5, which if we take 10 over 5 out, 10 over 5 is 2. So it's 2 and 4 over 5.